process and how things work behind the scenes, a lot of my presentation will bounce between a PDF that I have on the screen right now and then actual kind of files related to the design of, as you've read in the intro, we made some face shields, and I say we because I represent a collaborative effort across many parts of campus that responded to the crisis in this very narrow and specific way that was useful at the moment in which we did it. And those are kind of some of the themes that will pervade my talk. I am also going to do at least 5 minutes about art because I am from the Department of Art, and I just wanted to give you the context for which I kind of got involved. So just, what's face shield? I didn't put my face shield on. You guys a thing we never thought, all the things we didn't think we'd know anything about, like PPE as an acronym, right? This is a face shield. It's a thing. I think you're probably aware of what a face shield looks like. I won't talk with it on because presumably that blocks the microphone. I thought I would there's a wonderful array of promo material that I can now leverage here. Oh, that's the one I closed. 1 second. Sorry, everybody. I closed one thing. This is my big mistake. I closed one thing and then suddenly I can't find it. That is here we go. Let's just play the 1-minute UCI video that explains the project. So that's the face shield. It's a shield. It's one of our various personal protective equipment items that helps us respond to the crisis in a safe way. And the question that, I'm going to talk about design in a meta sort of way. Like, what is it to be a designer in a crisis? And what does that look like from the inside? And it does beg the question, what is design? And the follow-up question, which is, where is it? Why me? I'm scrolling ahead. How did I get involved in this as a person in the School of the Arts? I've completely given away the punchline here. When I teach design, and Alejandra took this class in the spring, so this is very kind of in real time, I wind up struggling a little bit to introduce a group of students to the notion of design, a thing that everybody has, a word we have all heard, and yet is very difficult to define. This is the design historian John Heskett, who talks about the problem of the word design in the following way. Design is to design a design to produce a design. And what does he mean by that? And I'm going to quote from him. Discussion of design is complicated by an initial problem presented by the word itself. Design has so many levels of meaning that it is a source of confusion. Consider, for example, the shifts of meaning when using the word design in English, illustrating by this nonsensical sentence. Yet every use of the word is grammatically correct. A noun indicating the general concept of the field as a whole, so the first design, as in design is important to the national economy. The second is a verb indicating action or process. She is commissioned to design a new kitchen blender. The third design is also a noun meaning a concept or proposal. The design was presented to the client for approval. And the final use is also a noun indicating a finished product and kind of what we conventionally think of as design, the concept made actual. The new Volkswagen Beetle revives a classic design. But this is one of these words like that we throw around in your education in particular. Those of you in engineering, you do senior design. And when I was an engineering student, I started off as an engineering student. There was no such thing as senior design. We talked about being engineers as a kind of independent activity. And nowadays we're all expected to be designers in some way, and yet design is kind of a nebulous task. When I learned to be a designer, and I ultimately trained as an architect, we would have thought of design as, you know, the creation of artifacts that address needs. This isn't an arbitrary definition. Each of these words is important. The word creation, the creativity inherent in selecting, you know, the decision-making aspect of design. The word artifacts, suggesting, you know, you make something, a widget, a computer mouse, you know, a cup. And then address needs is a funny way of talking about, it's not a solving a problem. Designers like to talk about solving problems. Engineers do too, but it would be more accurate to characterize the act of design as, you know, you need to make an ad campaign. You're addressing a need, a marketing need. Is it solving a problem? You know, that's an open question. But it's not as simple as even this. Even though I, you know, trying to come to the table with a clear definition of design, I have to complicate it in two ways right away. In the 21st century, designers are often called to do something other than create an artifact. They're asked to create a system. And this is maybe how this connects to the Internet of Things most directly. You know, we're no longer in a universe of discrete artifacts. We're in a universe of interconnected artifacts, whether they're physical or virtual. And things like user experience design, where where the designer is in fact designing no artifact, designing a way of interfacing with a computer at the front end and the back end, would be a good example of that professionally. And then 2020 comes along and COVID comes along, and we've got a slight new variation that is an important distinction. You know, we're not addressing a need in a broad sense or in a long-term sense, and there isn't a commercial imperative, at least initially. And this project, of course, you know, it dates back to the very beginning of the COVID crisis. We're responding to a crisis, and I just want to highlight that distinction between addressing a need and responding to a crisis. And because the way that this design story plays out, I think this difference is important at every step along the way. So then the title of my talk is a design chronology, and, you know, begs the question, well, why are we talking about this chronologically? Why don't you just show us the design? And the design is interesting, but you know what? It's actually a pretty simple thing. It's a piece of plastic and another piece of plastic and a piece of elastic. And it in fact is completely borrowed from another designer, as I'll talk about in a second. There's not a tremendous amount of invention in the artifact itself. This is my first chance to talk about this project in any kind of public setting, and I've, you know, in thinking about how to talk about it, I think the most interesting thing, especially for a group of students who may or may not be asked to design things in the future, is how did this play out over time, and how does time play, and how does this chronology, this sequence of events, impact the set of decisions that were made. Also, I have this folder on my desktop called COVID Face Shield Project. And it starts on a date, the 23rd of March. And it, you know, I have Neil is here, and I'm going to introduce my team briefly, all the way up to a couple of days ago. You know, this is the chronology of this project. It's not over. I talk about its dissolution. It's kind of wound down, but it's still active. And all of this work is done in the context of my lab in the School of the Arts called the Speculative Prototyping Lab. I am tickled to know that my relatively non-updated website features a picture of another UROP and Surf IoT project from olden times, pre-COVID times, where we built some things with bicycles that I won't talk about today. But I did think I'd just quickly show you my lab website and introduce my team, who's all here. Over the years, I run a lab in the School of the Arts that is not funded in the conventional way, and doesn't take in students in a conventional way like a science or engineering lab might, where it kind of supports a student's education. So participation and activity in my lab is contingent on there being a project to work on and there being some funding for that project, and generally is shorter lived. So since 2015, I mean, Saeed and GP, I think you'll find that every single one of these activities was in some way supported by Europe or Cal IT2 in some way. So we thank you for that. And our current crew consists of, for the first time, we have a kind of guest member of the lab that's a lecturer in the School of ICS, Neil Young, who's here, who spoke and helped us set up, fix the Zoom. We have a grad student, and that's, there's a typo. We have Alejandra and Ananth, our two students, two undergraduate students. And then we kind of have some staff members that are exiting the lab at this time. Okay, let's go back to the presentation. But thank you. So thank you to my team for coming. And we actually hope to, use the Q&A period to ask some important questions about the work we're doing now. So I had to go back and look, like, how did this even start? Of course, I've long forgotten. We've all forgotten what it was like to be in the middle of March. And well, what it was like for me was I was wringing my hands, like we all were, about both, what's going to happen, and also what can I do to be helpful. It was the beginning of the new quarter, and I got this funny email from Carolyn Stevens, and I found you the actual email. This was the whole email. No text in the body. 7:28 a.m. Call me. And so I believe I called her pretty much right then and there. If I look through the rest of the emails that day, I must have called Carolyn at 7:30 and said, hey, what's up? And we had worked together. Carolyn runs enterprise collaborations at Applied Innovation, and so was putting together a series of, so I learned, a series of teams working on identified priority projects for the UCI Medical Center. And the face shield was one of them. This is all to point out that as the designer of the face shield, it was not my idea to make it. It was not me who identified the need for the face shield. That's not something that, as a designer, I had any access to. Certainly I was wondering, but Carolyn, who was in contact with Pramod, who's our Vice Chancellor of Research, and the leadership at the medical center, determined there were 6 things, I believe at the time, that were high priorities. One of which was there was a shortage of this frequently used medical product that suddenly was in huge demand in the middle of March, and there was there were none in the United States, and the medical center looked at its stockpile. It had around 10,000 at the time, and it anticipated burning through them at 1,000 a day in order to sort of keep safe. So this is how things started. And then the question, why me? Well, Carolyn knew, and was paying attention, I guess, that I had created an art project that I sometimes call the biggest thing ever made with small 3D printers, and somehow in her intuition recognized that this would be useful in this. And this is my 3 minutes of telling you what I do most of the time when I'm not making face shields. As an artist, I have a whole variety of projects, one of which involves, and maybe I should pause there because there's some confusion. Is Jesse an engineer or an architect or an artist? And I am those things in that order. I am now an artist. I started out as an engineer and then became an architect and am now an artist. And all of these things kind of collide into one package. And the project that most strongly leverages all 3 of those disciplines would be this one, which I'll show you now. So this is what I had been doing, and what's not shown in the little promo video, basically about my artwork. Thank you for um, suffering through that. Is that these are all made on a 3D printer farm housed in the School of the Arts, funded by actually a collaboration between art and engineering and Cal AT2 and a couple of others. That we printed 5,000 3D printed things, and they were, relatively customized. This is a unique object made on campus. And it turns out there aren't actually a lot of, there's lots of different kinds of manufacturing ability built into labs on campus, especially at the nanoscale. This would be a very common thing on campus. But there isn't really a lot of places where you could make 5,000 of something. And that was the thing that I think Carolyn realized was, well, maybe Jessica can help us make 5,000 of something, or maybe more than that. And that's in fact what we did. Although, as it turns out, any of you who've done any 3D printing, terrible way to make things. Just, you don't want to make 5,000 things with 3D printers. But the expertise associated with manipulating geometry for the purpose of digital manufacturing is portable. It kind of crosses over between technologies. And as one of a fairly small number of broadly trained designers on campus, this made me useful to the project. So this is what we did. We went on the internet of things and found some things. And as I look back at the date of this, curiously, this particular design, having been asked, how can we 3D print a face shield? And I typed in, as you would, 3D printed face shield. The one that came up and was, well regarded on March 25th, an important detail, on the day that we were asked to do this, was this one. This is a Swedish designer named Eric, who goes by the name 3D Verkstan, and he had come up with a, what seemed to me as an expert in this kind of technology. Okay, that makes sense. We can make that. Let's start trying that. And this is their design, and that led directly to our design. UCI's design is a direct evolution of the 3D Verkstan design, modified for our specific circumstance. Modified in a few different ways. One, we did a series of informal user trials with the hospital. So we had 50 doctors and nurses test a few design variations. This is all done very quickly. We had, as the promo video says, we did this in 11 days total. So we got 50 prototypes of various types in front of medical professionals. It was modified for the type of manufacturing we had. You'll notice this split and these zip ties. You'll notice that there are two different materials. These are effectively functionally the same object. One is made out of laser cut acrylic, one is made out of 3D printed plastic. Both cases, it features a joint in the middle. This is to make it efficient to make. This is so that we could take the pieces and lay them out on the machines. In this case, cutting the profile out of acrylic sheet, and in this case, stacking them on the bed of a 3D printer and having them be made efficiently. And that's where we wound up 11 days later. I mean, there's really, the story is not that complicated, the initial story. What became interesting as a designer was this, in a crisis, so responding to a crisis, was how quickly this became of interest to others. And I'm very proud of this project, but I'm also to some degree mystified by some of this, because it turns out that in early April there was, as there is now, a great deal of hunger for something to celebrate. And this became something to celebrate. And there are a half a dozen radio and television spots you could pick. I picked the one in Spanish because, interestingly, it's the most accurate. So for those of you who can, I'm going to play it because it's a couple minutes long. Also because it highlights the co-designer of the shield itself. So Ben Dolan runs the facility Rapid Tech and FabWorks in the School of Engineering. One of the challenges we had right away in those first 11 days was keeping track of who was involved and trying to make sure that everybody felt celebrated. And Ben and I very much co-designed the geometry of the final product. We ran the user testing trials together, but as a faculty member, to be frank, I'm more celebratable than Ben is as a staff member. And so this really spoke to the ecosystem of people involved in this project. So they found a picture of Ben and put it in their video.
que sigue ayudando durante esta pandemia, los técnicos de una universidad se han adaptado a las necesidades que ha creado esta crisis y empiezan a fabricar mascarillas.
Excelente idea, pero no lo hacen de una forma tradicional. Ellos utilizan la más alta tecnología de diseño en 3D. Rosa María Irvine nos explica cómo se está aplicando esta avanzada tecnología. Buenas tardes, Rosa María, vamos contigo.
Así es, gracias, muy buenas tardes. Cuando la comunidad universitaria de Irvine se dio cuenta de que requerían con emergencia mascarillas para todo el personal de salud, se pusieron manos a la obra y sacaron un exitoso proyecto. Ante la emergencia del coronavirus y la necesidad de tener máscaras seguras, Ben Dolan, director técnico del Instituto de Diseño e Innovación en la Fabricación de la Universidad de Irvine, comenzó a revisar los proyectos y materiales en Internet para protectores faciales impresos en 3D. Pero estos escudos se tardarían más de media hora en imprimirse, así que en colaboración con Jesse Jackson, profesor asociado en la Escuela de Artes, diseñaron un marco acrílico que podría ser cortado con láser rápidamente de 3 a 5 minutos. Este profesor creador nos comentó cuántas máscaras van a donar.
Son máscaras por los personal médico, 5,000 por el hospital UCI.
Finalmente,
Don't volunteer to speak in Spanish if you can't speak in Spanish. This is the this video also highlights, I'm going to fast forward a little bit, the involvement of UCI medical school students. So this is a person who can speak in Spanish.
Un proyecto muy fabuloso porque tenemos un equipo con miembros de muchas escuelas de UCI, como la Escuela de Medicina, la Escuela de los Artes, de Ingeniería.
estas máscaras están diseñadas solo para protección del COVID-19. Al principio la idea era para uso desechable, sin embargo, podrían reutilizarse después de ser limpiadas con alcohol o no utilizarlas durante 3 días para que se desinfecte. Sin duda alguna.
Okay, I'll pause that there and go back to talking about it. The video touches on inadvertently one of the things that all of media coverage focuses on is the technology. And as people who know technology, I'm going to make an assumption here that as a group, you're quite tech savvy. The technology is not actually that interesting. You know, laser cutters, 3D printers, they're interesting, but they're also they're sort of easy for media coverage to latch onto. The challenges as a designer that I faced with this project were not technological. I mean, I can make a 3D printer make something, and I can make a laser cutter make something. The two big challenges in being asked to make as many face shields as quickly as possible were people and logistics, which are kind of two sides of the same coin. So the people came from, we became aware that the first year medical student class, or the incoming class, or the first year students in the med school all wanted to do something. And those pictures are showing, we had around 30 or 40 students working shifts, kind of day and night, assembling the face shield. The face shield was not, you know, it doesn't make itself. It has assembly steps, and this became, you know, the biggest barrier to getting these done quickly was actually taking the pieces which the machines could make at a certain rate and then assembling them into functional devices. And to show you a little bit of this video.
Hi, I'm Irvine G. from the UCI School of Medicine, and I will walk you through face shield assembly.
All right, so we're gonna assemble the visor first. It's two symmetrical pieces. You wanna overlap. You take one zip tie, feed it through the top. The other zip tie, you wanna feed it.
I'm just gonna scrub through this, and lo and behold.
And cinch it as tight as you can, just like that. All right, now, and finally, we're gonna attach the shield to the visor. So you wanna start at the end, put it through the first hole, and you just wanna walk it along, pressing it through as you get to each corresponding hole. Pop it on, move to the next one. And this last one's gonna be the trickiest, but you just got a little bit of extra pop, and there you go. That's a completed face shield.
And so in 11 days, we made 5,000 of these and dropped them off at the hospital. And I think at that point, we weren't sure if we were done, but we were certainly on pause. And this quote basically says, I was just so happy to get to do something that was useful. As a person who had a certain set of skills, you know, we all contributed to the crisis, and we continue to contribute to the crisis in whatever way we can. And I count myself lucky to have been able to do something so directly impactful. But everything comes to an end, and this project is not over. But it did end slightly. I had in the excitement of having made something so grandly, I wrote a grant in the hopes we'd get to make more and other things. And this grant was, I have a blank slide here because we didn't win the grant. Academic life continues as it always has, and grants are hard won. My lab was not funded to continue this work, and there's a whole set of stories there. I'm not here to complain about that, but just to point out that at some point real life had to come back into the picture, and I started wondering whether we could pivot our creative activities towards more emergency activities. And it turns out, at least from the perspective of this particular grant opportunity, the answer was no. But we didn't stop. And actually, the other thing I wanted to talk about, I talked about people, and I mentioned logistics. When I talk about logistics, what I really mean is money. Money and time. And I'm actually going to skip ahead to a later spreadsheet because I think it's more informative. This was not a project that was divorced from the realities of everyday life, and from, you know, we were not throwing as much money as possible at this. In fact, it was quite a tightly constrained project. The goal was to make a face shield that cost $2. And in industry, that would be completely straightforward. You know, there would be no difficulty if you're going to produce 10,000 or 1 million of something to make something cost $2 like this. It's a very simple object. But for us, this was not easy. And this is just, I'm just not going to go through the weeds of this, just to show you the kind of analysis required. And if all of you engineering types or science types have made many a spreadsheet, and you know, you will continue, be good at spreadsheets. This is another piece of life advice. Be good at spreadsheets. They are the most important tool you have at your disposal most of the time. This spreadsheet is showing the 3 different methods in comparison. So there's laser cut and 3D printed. And it's also working through, and there's a few I'm just going to show you, working through various scenarios of time. How long would it take us to make 15,000? And comparing them to the burn rate in orange here, it's hard to see, is the burn rate at the medical center of 1,000 per day. Is the medical center going to run out of face shields? We paused production of face shields for 2 weeks, which was a mistake, because 2 weeks later, it was determined that there were still no face shields in the world. There was an expectation that industry would very quickly bounce back, and it didn't bounce back as quickly as was hoped. So a couple weeks later, we were asked to go back to the face shield drawing board and make 15,000 more face shields, which we did by the 15th of March. And I wanted to show you, of course, as a designer, I'm not going to stand still. We improved the 3D printed and laser cut designs, but at some point, it was inevitable. Let's make a proper product. Let's get out of manufacturing these things with tools in our labs, and let's make ourselves a nice injection molded object. And that's where this project ended. I mean, we basically got into the business of making near professional grade lightweight face shields. And you know, for the purposes of Q&A, I have envelope upon envelope. I have 7 envelopes of prototypes that lead from, these all look like they're exactly the same, but this bag is, you know, this is the bag exclusively looking at injection molded prototypes. One of the small challenges we overcame in the design process was a buckling issue. So those of you in kind of structurally inclined, we made some designs that started to buckle as you tried to put them on your head. This is a kind of a version of lateral torsional buckling that, you know, was going to make this a non-viable product. So we had to be very, very careful in our pivot towards injection molding, because when you injection mold, and I'll show you that very quickly. I'm just kind of I just have lots of different things to show you. It's a wonderful process. You in this case, we're using the company in I believe Minnesota called Protomold. Send them the file, have a back and forth with their engineers, and 10 days later, 10,000 parts arrive at your doorstep. And this is what, this is what real life looks like. This is not making things in your basement anymore. This is ordering parts, and this is of course what that costs. But if you divide that by 10,000, it's a fairly high value proposition. They also gave us a discount. The other thing, and I'm gonna cut some of my conversation short for the sake of having Q&A period, was this isn't just as a design project. It's a product, it's an object, it's an artifact. But it's also a part of culture, and no better way to connect this with culture than to show you my kind of Instagram life through the face shield, starting on March 14th, and then suddenly my whole life is taken over by questions of face shield, 3D printed prototypes, or the 3D printed objects, the shield itself, the packaging that we made to deliver them. These were delivered as per industry standard, individually bagged, dropped off for quarantining at the hospital in batches of 5,000. Other parts of life. This is the injection molded parts arriving all at once. So this is our kind of revolutionary moment where it's like we get out of 24-hour laser cutter running, and but that precipitated new design problems where we needed to create ways to cut some of the other parts quickly. And here's the kind of final team of people delivering the last batch of 10,000 on May 15th. At this point in the wind down of the project, we're doing two things. One is I've created an artwork that will hang in the lobby of Applied Innovation. This is a mock-up of it. It makes use of all of the waste material created in the process of making the face shield. So there's the kind of vestige of 20,000 face shields in this thing. This is 8 feet by 5 feet. It will hang in the lobby, and it commemorates not so much my involvement, but the fact that Applied Innovation provided the staff and the people in the long term. So everybody who works there will get to see a celebration of their labor, and that will go up shortly. But more importantly, as designers, and this is sort of shout out to my team again, is what do we do now? I mean, we effectively don't need face shields anymore. In fact, and I want to show you one last thing in my PDF stack here. It turns out we never really did need face shields. And this is one of the ironies of crisis response, is you don't have complete information. And I went and mined my email. I was looking for something else. This is an email I received on March 13th, showing me that we could have bought for $1.25 face shields directly from a supplier I had in China for something else that had already pivoted towards face shields 2 weeks before we started making them. And this isn't to say that what we did was wrong. It's just to point out that all design processes are make use of limited information, especially in a crisis. So I'm super happy to have gotten involved. But it is interesting that in fact, for cheaper than $2, we could have bought a perfectly acceptable substitute right from the beginning. So we're being a little bit more judicious in our energy, and I just found this today. This is one of the craziest things I've ever seen on Amazon. A person who's selling on Amazon a clearly 3D printed object for $11, and yet it is also America incarnate. It's an opportunistic response to another potential need, which is how do we open doors? More interesting to us as a lab are maybe more sophisticated responses to how do we mitigate, and maybe in a more subtle way than masks and shields, how do we mitigate the danger associated with commonly used infrastructure? So there's also, so we're kind of casting a wide net and evaluating available solutions to what we're calling hands-free OC, and hoping to find a community partner like a school district or a UCI unit that would like to retrofit all of its doors in ways that would make it safer for people to operate those doors. We know that we collectively know that transmission via surfaces is not strong, but there is transmission via surfaces, and there's no reason to not kind of change that infrastructure a little bit to make it safer. And maybe on that note, I will be done, and we can have some Q&A. Thanks, everybody. Let me unshare my screen here. And I guess if any of the students have any interest in knowing more about any of the design parts, I have my little archive of material, and actually I didn't wind up showing you the 3D modeling files for lack of time, but would be happy to do that.
Thank you so much, Jesse. I want to invite everyone to turn their cameras on if you wish, and then invite your questions. Any volunteers, or should I call on you?
Can I ask a question?
Yes, GP.
Thank you so much for outstanding talk. I have a question for you. Your previous project, before you work on this PPE device, you're talking about recycle.
Oh yeah, I didn't.
So right now, when you work on this project, we use quite a bit of plastic, and there will be so many plastic waste. And when I watch news, I was so concerned about how that may pollute the oceans. So what is your solution? This is a real life cycle, right? So that pollute the environment. So what is your suggestion for your creative mind, creative solution to solve that problem holistically?
I mean, I have so many different answers to that question. None of them are solutions. They may address a need, but they don't solve a problem. The one is just what Saeed is referring to. I'll just share my screen again quickly. Is an outgrowth of a Europe project was Closed Loop Plastics, a startup company in how do I close there? Here we go. Based in Long Beach, that makes 3D printer material out of recycled plastic. So this still that solution is still viable. But the reality is, I'm very proud of this company, and these are three UCI students, all engineering students who have gone on to and are still alive. It's hard to have a startup, but they're still making it. We have a design competition for those of you who are students. This is a design competition to make basically a recycling bin that would collect materials that would be turned into 3D printer filament. The issue is scale, and I think any of us who've kind of dug into this problem. I'm going to unshare my screen. The scale of the recycling issue is orders and orders of magnitude larger than any kind of small or even large business could make use of. And if you're right, I mean, we've generated, not only did we generate a waste problem, we suspended a number of things, like we're giving out cheap bags again, and masks are everywhere. It is such a wicked problem. We don't have a culture of, one of the most interesting conversations we had, and Neil, who's on the call, has some interesting ideas on this, is could we clean the face shields? The hospital system is organized around disposability for safety reasons, and has been, and always has been, and will continue to be. There was a moment early in the crisis when hospitals started reusing things that they'd never reused before. We've all heard of this: masks and shields, in particular, face masks in particular, were in short supply. And so, hospital employees and frontline staff were being asked to wash things, and it begged so many questions. Well, how do we wash these things? Where do we wash these things? Who washes these things? Hospitals are not organized around, just to take the hospital example, the face shield itself could be washed. It could be autoclaved. It could be made sanitary, but the systems in place, and we talk about system design, the systems in place in the hospital network in all of North America are not designed around collecting those goods. They're collected in biohazard bins and then incinerated. We would need to have, even within that very small part of the economy, this complete shift towards reuse of things. So that's not a solution, but it's such an interesting problem. I mean, I hope that some students in this group will be inspired to work in this area, because there's a huge opportunity, and it's a tremendously challenging problem, changing the culture around how things are used.
Thank you.
So let's invite the students. We want to hear from you also. And Judith, what do you think?
I think I like the idea behind it. One question I did have was for those like handless door openers, like the ones you put on the foot or to open with like your arm, why is it that most like, I would say businesses don't have it? Is it in relation to like cost, or what would that be?
So we've been looking at this quite carefully and are trying to understand the problem space. You know, as designers, it's not about the product. It's about what is the the surrounding issues around this product. So a couple of things that have come up that are really interesting. One is at UCI specifically. So Neil has gone and talked to EH&S, our health and safety, and the fire marshal about retrofitting doors on campus with a kind of lever that you can engage with your elbow. Two problems come up. One is that they're not fireproof. The second is that they're not ADA approved. They modify the design of the door in such a way that we would need to. And so this is not, neither of those groups are wrong. They're simply approval processes in the way of retrofitting doors, which is why we wind up in the door hook, which is actually a much less effective way of making doors safer, because it requires the user to remember to use the door hook. Whereas retrofitting the door altogether, like redesigning the door so that it doesn't require your hands, it would be a much more effective solution, but butts up against other design problems. And I don't think, and then of course there's always liability concerns across the board. All these projects, pervading all of these projects, are questions of liability and questions of who is responsible should any of these things fail. The door hook, if you pull on it too hard, it snaps. And if you're drunk or it's dark or you're tired, you could fall over backwards and crack your head. I mean, this is a very real problem. And I don't know, Neil, do you have any thoughts on that question? I'm going to invite a member of my group to jump in if they have any.
No, liability kept coming up as a key concern. I actually had one retirement home. The facilities management was very interested in these. He wanted us to get him as many hands-free devices as we could. He sent us pictures of his doorknobs, that kind of stuff. And then the executive board was like, no way, unless you can give us certification that these are fireproof and can be cleaned and all that. And so the fear of liability has really hindered our ability to produce and distribute those. Back to her earlier question, from my sense, the main reason you don't see more of these, and you do see them occasionally, is that places don't know they exist. So what I encourage you to do whenever you go somewhere and you see that they have a door handle that people are going to have to interact with a lot, just tell them, you can buy easily, not cheaply, like it's like $40 for the foot ones, but it's a retrofit they can do in a few minutes. And I'm encouraging places to do it. So you can even, whenever you go to the store or wherever, any place that has doors that seem suitable, let them know about these.
So say if the handle is still in place, like you can still put those even though if they're not like fireproof, just for options, or is that still not like legal?
Well, it's certainly not the kind of thing where, it's up to the businesses to make that calculation for themselves. What kind of things? What I recommend to places are foot-mounted ones where they actually attach at the bottom of the doors and don't interfere with the door handle at all, because it sidesteps some of those concerns. It's not ideal though, because for some doors, you have to actuate the handle to open them. For doors where it's just like a heavy door with a handle, those work well though.
And in the big picture, the students in the group, I'm not recommending that you all become lawyers as well, but I have to say, you've got two choices when faced with a liability issue. You can be frustrated, which we all are. Every one of us has butt up against some kind of liability issue at some point in our careers. But the interesting problem is not to be frustrated, is to sort of figure out what the risk issue is and mitigate the risk. I mean, there is always a path forward when in mitigating risk issues. And we got through them with the face shield. I mean, you think about it, the exposure of building face shields for a hospital, there's no, so there were people well above my pay grade that had all sorts of conversations about, can we even do this? Can we make a bunch of things in our facilities at UCI and provide them in a medical environment? And it was ultimately decided that the risk was worth the benefit in that case. And I think what we're butting up against with these door handles is that people are not perceiving the benefits to outweigh the risks yet. We've been trying to make sure we have a handle on the science that we can quickly distribute. I mean, there's no shortage of evidence that suggests these improvements would make, that would save lives. Maybe not as many as masks, but a measurable, quantifiable number of lives would be saved by people not touching doors. But it's not as high a threshold as something like mask use. It's on maybe an order of magnitude fewer lives. So suddenly liability becomes a bigger concern. I think the combination of legal cleverness and design is a very powerful pair of tools for students to explore as a career path.
More broadly, because of how liability works, institutions or businesses are very hesitant to change their physical environment. It's often designed around these invisible concerns that we're unaware of, that the architects are aware of. So what you'll notice, like when you go to many businesses, is if you request a mask from them, they'll give it to you. So you might encourage them to do something like that, where, hey, you can buy a bunch of these inexpensive hands-free door openers and just offer them to people by request. It's not an ideal solution, but it sidesteps some of the issues that will prevent places from doing nothing.
Jesse, thank you for a fantastic presentation. I have to zip off to another meeting. I just want to say
I believe I have to join Stephen at that same meeting, so
and
I'll stick
I look
around
forward to it.
Bye, Stephen.
Yeah. Thanks, everybody.
Thank you, Dean Barker. Again, in the interest of time, let's give Associate Dean Barker a hand and thank him for a great presentation. And you can always I don't know, Jesse, you probably need to leave, so thank you again. And
if anybody has a question, I can take one more. I mean, I'm not urgently needed in that other meeting, but if there's one more student question, I'd be happy to.
Oh, okay.
If there isn't, then.
Anyone else? Okay. Thank you again. Thank you again, Jesse. I mean, I was gonna comment that I see when you look at the face shields, the mask, the goggles, right? The fact that we measure temperatures. I'm wondering down the road, is there a way to integrate some of these things? Maybe we can put like a little sensor on the inner layer of the face mask to measure temperature, and then that will give us an automatic reading. I don't know, I'm just thinking out loud. The cost will increase, of course, but then you're integrating functionality in one piece. I don't know.
We're well on our way to being robots already. So, if Elon Musk has his way, we'll just send our temperature to the, the network automatically and problem solved.
Well said. Everyone, have a nice afternoon.
Bye, everyone.
Thank you.